Hi everyone, it's me again, Princess Bugambal. This is the continuation of our video for rational functions. If you missed the presentation prior to this, it talks about the restrictions of domain. Now for today, we will continue our lecture by finding the domain and range and the asymptotes of a rational function. So again, this is Princess Joy Bugambal, and I will be guiding you all throughout the course in general mathematics. If you have any problems, questions, or clarifications, please do leave a comment and I'll be glad to assist you. Kaya mga ka-MATHerrifics, let's start! From our previous lecture, we talked about domain and range. Domain is the first value or the first element of an ordered pair or the components of x, while the components of y is called the range. So let's have an example. I have here sets of ordered pair. We have 2 and negative 3, 4 and 6, 3 and negative 1, 6 and 5. Now, what are the values of domain and what are the values of range? Now, as you can see, domain or the values of domain are 2, 4, 3, and 6. How did that happen? Again, domain is the first element of an ordered pair or the values of x. And for the range, the second value of an ordered pair, which is negative 3, positive 6, negative 2, and positive 5. Now, how about in finding the domain and range of a function, a rational function to be specific? So I have here two examples, x minus 3 all over x minus 4 and x squared plus x minus 2 all over x squared minus x minus 2. Okay, so from the previous video, we learned about the restrictions of domain. Now, how about if you are asked to find the values of domain and range? So, from the last slide, domain are the first value of our ordered pair or the values of x, while the range are the values of y. So, for this instance, I have here a function x minus 3 all over x minus 4. Now, we are looking for the values of domain and the values of range. Now, let's have this first. For the values of domain, we can only identify that using the restrictions of domain, meaning to say, we have to look for the extraneous roots. So again, where can we find the extraneous roots? Okay, extraneous roots can be found in our denominator. So let's take out first our denominator, x minus 4, x minus 4, then zero product property, equate this to 0, then the value of x is equal to 4. So this will be our extraneous roots, meaning to say the value of x are all real numbers except number 4. Because if we use the value 4 and substitute it in our rational function, the function itself will be undefined. Okay, so I also taught you about the answer for domain in set builder notation. Our domain are the set of values of x such that, or set of real numbers such that x is not equal to 4. In short, this tells you that our domain are all real numbers, positive numbers and negative numbers including 0, except only for positive 4. Okay, now how about the range? Our range are the values of y. So I can explain this through the graph. Okay, using the graph wherein you can easily tell what are the values of y as long as the values of y will not make our function undefined. So that's just the same with our domain. Okay, so I will show you the graph. Okay, so now we know how to locate or to find the values of domain. Now, how about the values of our range? Okay, so here is the graph for our rational function x minus 3 all over x minus 4. Now, as you can see, our graph is asymptotic, and As you can see from my picture, the graph covers all values of y. Okay, just a reminder for all of you, the horizontal line. Okay, so the horizontal line is here, is the y-axis, and this is our x-axis. Okay, or the values of x's. Now, as you can see from my picture, the graph covers all the values of y, right? The graph will go as low as I like, as high as I like, because it continues indefinitely. That means our range, or the values of our y, are all real numbers. That's how you identify the values of range. Okay, so disregard these dots. Okay, so it doesn't matter. I just showed you how to identify the values of our range. Okay, so let's have another example. We have rational function x squared plus x minus 2 all over x squared minus x minus 2. Now let's identify first what are the values of domain, or the values of x. Okay, so again, in identifying the domain, we have to determine first what are the extraneous roots. And extraneous roots can be found in our denominator. So we have x squared minus x minus 2. Factor this one out. So factors of negative 2 is 2 and 1. So this is negative and this is positive. Now again, if you want to check if our factors are correct, you just have to multiply this. Multiply positive 1 and negative 2, that is negative 2. Then add, it will result with negative 1. And that is the same with our middle term. So therefore, our factors are correct. Next, in identifying the domain, equate these two factors to 0. So we have x plus 1 is equal to 0 and x minus 2 is equal to 0. Let's find the value of x for this one. So we have x equals negative 1 and x is equal to positive 2. Therefore, the extraneous roots are negative 1 and positive 2. Meaning to say, our domain or the values of x are all set of real numbers such that x is not equal to negative 1 and positive 2. Again, in short, our domain are all real numbers, positive numbers, negative numbers, except for these two, negative 1 and positive 2. Now, how about in getting the range? Okay, so like what I've said a while ago, you can identify the values of y by assigning or plotting the function itself in a graph. Okay, so let's identify first the graph. So here is another graph for our example number 2. For our function x squared plus x minus 2 all over x squared minus x minus 2. Now, as you can see, our graph seems to be a little bit trickier than the first one. But as you can see, I'll zoom it out, and our function continues indefinitely. Okay, so another thing, the graph covers all the values of y. So meaning to say, you know the answer, the values of our range are all real numbers. Now let's proceed with asymptotes. The asymptote of a rational function is a line or a curve that the graph of a function gets closer and closer but does not touch the axis. There are two types of asymptotes. Number one is vertical asymptotes, which are the vertical lines from the extraneous roots of the domain of a reduced rational function. While the second one is called the horizontal asymptotes, which are the horizontal lines the graph approaches. Now, let me emphasize this one. Vertical asymptotes are the x values or the extraneous roots of the domain. On the other hand, horizontal asymptotes are the values of y. Now, let me give an emphasis for horizontal asymptotes. To find the horizontal asymptotes, number one, if the degree the degree is the largest exponent of the denominator is bigger than the degree of the denominator, then the horizontal asymptote is equal to 0. Now, if the degree of the numerator is bigger than the denominator, then there is no horizontal asymptote. And for the last one, if the degree of the numerator and the denominator are the same, then the horizontal asymptote is equal to the leading coefficient of the numerator divided by the leading coefficient of the denominator. Okay, so let's have an example. Let's find the vertical asymptotes of this for example. Okay, so let's try to find the vertical asymptotes for 4 examples. And I have here the first one. Rational function r of x is equal to 4x all over x minus 3. Now again, vertical asymptotes are the extraneous points of our domain. So meaning to say, for us to find the vertical asymptotes, first is to find the restrictions or the extraneous roots. So again, you know the process, the process of getting the restrictions or the extraneous roots. So our vertical asymptotes will come from our denominator. So let's take up the denominator, x minus 3, equate it to 0, then find the value of x, or solve for the value of x. So our extraneous root is positive 3. So meaning to say, our vertical asymptote is equal to 3. That's it. Okay, for item number 2, we have q of x is equal to 3x squared all over x plus 3. Okay, so again, we are looking for the vertical asymptotes. Look for the restrictions or the extraneous roots. Okay, so let's take out the denominator, x plus 3, equate it to 0. So we have x is equal to negative 3. So that means our vertical asymptote is negative 3. Okay, now let's have the third one. We have p of x is equal to 4x squared all over x squared plus 2x minus 8. Okay, so in this case, we have a trinomial which are factorable. Now, for us to get the vertical asymptote or the restrictions, let's have first the factors. Okay, so x squared plus 2x minus 8. Get the factors of negative 8. So that is 4 and 2. So let's say that this is negative and this is positive. Again, let's check. Negative 2 times 4, that is negative 8. Negative 2 plus positive 4, so subtract. Then copy the sign of the higher number, which is positive. So the answer or the factors are correct. Next, equate these two factors to 0. So we have x minus 2 is equal to 0. Same on the other side or the other factor, x plus 4 is equal to 0. Now solve for the value of x. X is equal to positive 2 and x is equal to negative 4. Meaning to say, our vertical asymptotes are positive 2 and negative 4. And for the last one, we have x minus 3 all over x squared minus 1. Okay, so for the vertical asymptotes, we have x squared minus 1. Get the factors of this trinomial. So we have x plus 1 and x minus 1. Then, equate it to 0. So we have x plus 1 is equal to 0. Same on the other side. Solve for the value of x, transpose. So we have negative 1. Then, positive 1. So that means our vertical asymptotes are positive and negative 1. That's it. Okay, so I'll give an emphasis on how to find the horizontal asymptotes. Actually, there are 3 ways to find the horizontal asymptote, as I have mentioned from the previous slide. For number 1, if the degree of the denominator is higher than our numerator, then our y, or the horizontal asymptote, is equal to 0. The higher the bottom, then our y is equal to 0. Okay? Next, for number 2, if the degree, let's have it in reverse, if the degree of the numerator is higher than the denominator, therefore, there is no horizontal asymptote. Okay? And then for the last one, if the degree of the numerator and the denominator are the same, again, they are the same, take out the literal, the numerical coefficient, then divide. Divide the literal coefficient, and that will be our horizontal asymptote. Okay, so let's have an example. From our example a while ago, I have actually 4 examples in finding the vertical asymptote. Now let's find its horizontal asymptote. For number 1, we have there r of x is equal to 4x all over x minus 3. Okay, so we found out the vertical asymptote. Now, how about the horizontal asymptote? Okay, so let's identify first the degree of our numerator and denominator. What is the degree of our numerator? The degree is 1. How about the denominator? The degree is also 1. Now, which case does it fall? Or our rational function fall? Is it on case number 1, 2, or 3? Since they are the same, it means we fall in the category number 3. Okay? So the degree of the numerator and denominator are the same. So that means we have to divide the, this should be numerical coefficient. So the numerical coefficient of our numerator is 4. And on this one, we have the leading coefficient is x. So we have there an invisible numerical coefficient of 1. So we have 1. Kindly divide, because that is the process for case number 3 or category number 3. So that means this is equal to 4. That also means that our horizontal asymptote is 4. Okay, you might be confused, huh? Horizontal asymptote is 4, y is equal to 4, that is just the same. Okay, next, number 2. What is our second example? Q of x is equal to 3x squared all over x plus 3. Okay, so which category will this rational function fall? Is it for number 1, case number 2, or case number 3? Okay, so let's identify first the degree of our numerator. The highest exponent is 2, while on the bottom, we have a degree of 1. So the degree of the numerator is higher than our denominator, right? So that means our horizontal asymptote is... Okay, that's good. None. There is no horizontal asymptote, since the degree of our numerator is higher than the denominator. Alright. Okay, for number 3, we have p of x is equal to 4x squared all over x squared plus 2x minus 8. Okay. So, for number 3, I think there is no need for us to factor this one out. Because we are just looking at the degree for the numerator and the denominator, right? So, we have degree. The degree of our numerator is 2. denominator is also 2. So it falls on the category number 3. That means we will divide leading coefficient. We have 4 divided by 1. Okay. So it's just the same. That's just a coincidence. Okay. So our horizontal asymptote is equal to 4. And for the last one, is rational function is equal to x minus 3 all over x squared minus 1. Okay. So what is the degree of our numerator? That is 1, correct? Degree of our denominator, that is 2. So as you can see, no, the degree of the denominator is higher than our numerator. So that falls in category number 1, which means our horizontal asymptote is equal to 0. Okay? Kindly take note of this. None is not the same with 0. This doesn't have a value, while this has a value of 0. Okay? In a number line or in a Cartesian plane, okay? In a Cartesian plane, so this is the y-axis and this is the x-axis. Okay? So if our horizontal asymptote is 4, so I will mark this here, and this indicates as the horizontal asymptote. Now on the fourth example, our horizontal asymptote is 0. 0 has also a value, and it also can be located at our Cartesian plane. Meaning to say, even though the value is 0, we should indicate that this is our horizontal asymptote. Now, what is the difference between HA is equal to 0 and none? If your horizontal asymptote is none, therefore, you don't need to draw it on our Cartesian plane. So that's the difference. Okay? So that's it. That's how you find the horizontal asymptote of a rational function. Alright, so let me cut this video with asymptotes. So please stay tuned for the next part and the continuation of this video. Our next video deals with graphing rational functions. So on that video, we will apply what we've learned from today. So again, this has been your instructor, Ms. Princess Joy Bugambal. I hope you've learned about the difference between domain and range, the difference between horizontal and vertical asymptotes. So see you on the next video. Bye-bye and God bless.